This unit that we're working on is graphing polynomials, actually graphing functions. We're going to start with graphing polynomials, and then we're going to also graph rational functions, as well as irrational functions, time permitting. We'll see how things go. But one of the things that you need to find is to find a zero. And we talked yesterday about, or the last section, about finding the number of zeros that there were, the number of positive zeros and the number of negative zeros, and then also finding using synthetic substitution. And so what we're going to do to start this is I first of all want to see how many positive zeros and how many negative zeros there are. And so I'm just going to go through that little process that we did before. For the positive zeros, I count the sign changes, and there are no sign changes. And then for negative zeros, what I do, and usually I just right above this do f of negative x, and it's going to stay positive. I just like right above it what the sign's going to be. This one's going to change negative, then it's going to stay positive, and then I'll count my sign changes 1, 2. So there are 2 or 0. So what this helps me with is when I am working through and factoring, I know that if I find a 0 here, there is another 0. Or if I'm going to be using synthetic substitution, as we'll do in a little bit, there are no positive zeros, so I'm not going to find, or I'm not going to try any positive values. So I just start by thinking about this. And then factor first if possible. If you can't factor, then we'll go into making a table, and again, we'll get into that in a little bit. So what I'm doing is I am going to take this basic trinomial and break it into a factor. I can use guess and check method. I can use the snowflake method, but this would break down to two numbers that multiply to be 15 and add to be 8. That's x plus 3 and x plus 5. Finding zeros means I'm setting them equal to 0. And so x plus 3 equals 0 and x plus 5 equals 0. So x is negative 3, x is negative 5. So my zeros are at negative 3, 0 and negative 5, 0. And that's exactly what I expected, 2 or none, and I did in fact get 2. So I'm going to go through that same sort of process with my next one. Just again, give me an idea how many positive zeros, how many negative zeros. So for positive, I'll count my sign changes. 1, 2, so 2 or 0. And then right above that, I'll do f of negative x. First one's going to be negative, stay negative, become negative. So now there are 0 negative zeros. So I will set this equal to 0 and factor if I can. I can pull out an x. That leaves me with 4x squared minus 4x plus 1. Let's see if I can factor that any further. I need two numbers that multiply to be 4 and add to be negative 2, but this is a 4 in front. So this might be one where I do a snowflake method for, because 4x and 4x, that 4 in front messes with things a little bit. And then up on the top, multiply to be 4, add to be negative 4. The only thing I can think of is negative 2 and negative 2. Remember, this can be reduced, so this is 2x and negative 1. Same thing on the other side, 2x and negative 1. So I have 2x minus 1, 2x minus 1. So when I set that all up, x is 0, 2x minus 1 is 0, 2x minus 1 is 0. This is a repeated 0. X equals 1/2. So those make up my two positive zeros. And so that's another indicator that's going to help me. If I find one and I can't seem to find another one, then it must be what we call a zero of multiplicity. So what I say is I have a 0 at 0, 0, that's once, and then I have a 0 at 1/2, 0, that shows up twice. And I'm just going to put a little 2 with a circle around it in the corner. That's showing that this is going to show up twice. What this means to me is at 1/2 on this graph, this function is going to bounce up. At 1/2, it's going to bounce up, and so that's a really helpful indicator to me. And then it must swing back down and cross through at 0. I made that a little steep there, swing back down and cross through at 0. So I already have an idea of what this graph looks like just by looking at the zeros. Don't worry as much about that right now. Again, we'll get into more detail with how that works when that time comes. So we're going to move on to our next one. I'm going to again go through positive zeros, negative zeros, 1, 2, so 2 or 0 again. For the negatives, it's negative, positive, negative, 1, 2, so that's 2 or 0. That tells me I have 2 or 0 positives as well as 2 or 0 negatives. This is again going to be real helpful when we get into our graphing. Right now I just use it as sort of a way to help me check my answers. Just a quick sneak back up to this one, 0, 0. That doesn't count as either a positive or a negative, just in case you're wondering about that. So my 2 positives come here. That's sort of an extra one that's in it. So I'm going to pull out an x, set these equal to 0, pull out an x. This is x times x to the 4th minus 2x squared plus 1. And don't get too worried about or worked up about this, because this is factorable like a trinomial as long as it's even and going down, like 4, 2, 0 or 6, 3, 0. Because it's broken down that way, I can factor this as x squared something and x squared something. So 2 numbers that multiply to be 1 and add to be negative 2. And those 2 numbers are negative 1 and negative 1. So now I look at this closely and I can factor that again. 0 equals x times x plus 1, x minus 1. I have to factor completely, times x plus 1 times x minus 1. So there are my zeros of multiplicity. I have 1 at 0, doesn't count as a positive or negative. I have 1 here at negative 1, at positive 1, at negative 1 again, at positive 1 again. So again, when I set my zeros up, it's 0, 0. Negative 1, 0, but that one shows up twice, and positive 1, 0, and that one also shows up twice. So there are my zeros, and I have 2 zeros of multiplicity. The last one where I'm going to be factoring, on this one I'm going to go ahead and again count my sign changes. For positive, I have 1. That's going to be negative, negative. For negative, I have 0. Set it equal to 0, pull out an x squared, x minus 1. So x squared equals 0. That means x times x equals 0. So that means x equals 0 and x equals 0. Okay, I know I made that kind of a long drawn out thing, but that means 0 is a 0 of multiplicity. And then x minus 1 equals 0, so x is 1. So I have 0, 0 twice, because there were 2 x's that equal 0, and then 1, 0 once, and there's my positive 0 that I found. I don't need to write the once there, but I already did, so whatever. All right, what if I can't factor? What am I going to do then? Well, then we do a table, and I'm going to do sort of a variation of our synthetic division table. What I do is I'll make this long sort of line here, and across the top I'll put my 1, 2, negative 7, negative 2. And when I'm working through here, again, I'm going to look for the number of positive and negative zeros. So 1 sign change, so I have 1 positive, and then it would be negative, positive, positive, negative, then I have 1, 2, 2, or 0. So what I'm going to do is I'm going to pick sensible numbers that can go in here. And sensible numbers come from a combination of the front and the back. Because 1 is in the front, I'm only going to look at the back. This means that the only sensible numbers for me to put in this table, the only sensible factors would be plus or minus 1 and plus or minus 2, because those are factors of negative 2. And so this is really just another guess and check situation. So what I do is I pick one that I'm going to try. I know there's one positive for sure. So I'll start with either positive 1 or positive 2. I'm going to do positive 1. So this is my quick version of this table. I bring down the original 1. So I'm going to multiply these together. 1 times 1 plus 2. That'll be the next number I write down. And I do 1 times 3 plus negative 7. That's the next number I write down. 1 times negative 4 plus negative 2. That's the next number I write down. This is not 0. Therefore, 1 is not a 0. Then it must be 2. So I'll plug in 2. 2 times 1 plus 2, 4. 2 times 4 is 8, plus negative 7 is 1. 2 times 1 plus negative 2 is 0. Aha! There is a 0. So I know I have a 0 at 2, comma 0, because 2 came out to be 0. Remember, that's f of 2 equals 0, and that's what that means. My input is 2, my output is 0. Next thing I'm going to do is called depressing this polynomial, because this was an x cubed. There's 1x squared plus 4x plus 1. That's my new polynomial, and I'm going to double check to see if I can factor that and set it equal to 0. So I need two numbers that multiply to be 1 and add to be 4. Not possible. Therefore, I must have no zeros, or my zeros, my negative zeros on the negative side, would require the use of the quadratic formula. So which we may get into as well. Maybe I'll try the quadratic formula. I believe if we try this one, negative b, let's see what we get here. So if I try that, I get negative 4 plus or minus the square root of 4 squared, which is 16, minus 4 times 1 times 1, all over 2 times 1. And so when I do my math, negative 4 plus or minus the square root, that would be 16 minus 4, square root of 12, all over 2, which tells me then my other two zeros are at negative 4 plus or minus the square root of 12 over 2 comma 0. So I'm not going to go and figure those out right now because I don't really need to put those in there. So let's keep moving on here. Because this next one has a 2 in front, that means that when I think about my possible answers, I've got to incorporate that 2. And so I'll start by looking for positive and negative zeros. Number of positive and negatives, I have 1, 2, 2 or 0 positives. And then this would be negative, stays negative, becomes positive, stays positive. Then I have 1 negative 0. And so now I'm going to go ahead and pick my, I want to go back to here again a little bit, sorry. Well, I'll continue. I'll go back to that in a little bit. But anyways, I'm going to pick my possible values to go in my table. This is 2, negative 4, negative 11, and 10. I'll pick again my possible values to go in. Possible values could be 10, because 10 goes into 10, or 5, because 5 goes into 10, or 2, because 2 goes into 10, or 1, because 1 goes into 10. And all of these are plus or minus. But then, because this 2 is here, I have to divide also by 2. So 10 over 2 would be 5. Well, I've already got that. So I could also try plus or minus 5 over 2. 2 over 2 would be 1, so I already have that. And then I could also do plus or minus 1 over 2. So it's every factor divided by 2. And if this were 4, I'd have to divide it by 2 and 4. So it kind of gets a little bit complicated. But these are all the reasonable problems that could work here. So I'm looking for the rational zeros. And that's what I wanted to bring up over here, what I was kind of got sidetracked on. This is an irrational zero. So technically I didn't have to put it in here. I was only looking for rational zeros. So this is an irrational zero because it's got a radical in it and it's not going to come out nice. So really the only answer I'm interested in is that 2. Okay, so back to this one. Let's we just kind of randomly pick a number. I'll pick 5, okay? Try to positive, picked 5. So I do 2, bring the 2, 10 plus negative 4 is 6, 30 plus negative 11 is 19. This is getting really big. 5 times 19 is 95 plus 10 is okay, I was way off on 5. Let's go a little smaller. Let's try 1. So 2, that's negative 2. 1 times negative 2 plus negative 11, negative 13. 1 times negative 13 plus 10 is negative 3. Still not working. Neither of these are working. Let's spice it up and let's try a negative, because I'm guaranteed to have a negative. So I'll put that in. 2 times negative 1, so that's negative 6. 6 plus negative 11 is negative 5. And then 5 plus 10 is 15. Still not working. I'm not having any luck. I'll try negative 2. So I plug in negative 2, that's negative 8. 16 plus negative 11 is 5. So negative 10 plus 10, I finally found it, negative 10 plus 10. So I have negative 2 comma 0 as a 0. Now I'm going to I'm going to go down here and depress this. It started out cubed, so my first one is x squared minus 8x, and then I just count down plus 5. Then I want to look for two numbers that multiply to be 10 and add to be negative 8. So when I set up my thing here, I'm going to have 10 on top, negative 8 on the bottom, 2x and 2x, because now I can factor that. And I think it's negative 3 and negative 5. And so I would get, that seems not right because it wasn't an option up here. Let me see. Two numbers that multiply to be 10 and add to be negative 8. Duh. What was I thinking? They add to be negative 8, but those don't multiply to be 10. So it would be 2 and 5. That's not going to get me, so it looks like it doesn't work. So again, this would be another one that's an irrational 0. So my final answer would be the negative 2, 0. Okay, unfactorable. All right, we've got two more that are like that. In fact, what I'm going to have you do is pause the video and give those two a try. See how you do. First of all, see how many positive and negative zeros. Make a table of possible guesses. In fact, let's go over possible guesses before we go on. So possible guesses for this one are plus and minus 1, plus and minus 1/2, plus and minus 1/4. Again, that comes from the end over all the factors here, which would be 1, 2, 4. So, and this one is only 1. So 1 over 1 is 1, 1 over 2 is 1/2, 1 over 4 is 1/4, and then I do plus or minus. If I'm doing the same thing on this next one, again, it's plus or minus 7, plus or minus 1, because those are all factors. 1 and 7 are factors of 7. Then over here is 1 and 2. So I do 1 over 1, 7 over 1, and then I also do plus or minus 1 over 2, and plus or minus 7 over 2. So all the combinations that I can get of possibilities. So these would be the problems that I'm going to guess. Again, pause here and then come back and revisit once you give it a try. I'm back, and here's how I did. I started out again by determining the number of positive and negative zeros. I made my little table, and then I thought about what I could use. So remember, we talked about this before we shut that down. So these were the things that I used. I knew that there was one negative for sure. So I started out with a negative, and I was really far away. And then there were 2 or 0 positives. And so I thought, well, I'll try, keep it small, I'll try 1. I don't necessarily want to try a fraction yet, even though I could, and it could work. I'll try 1 and see what happens, and thankfully I ended up getting a 0. So then I depressed the polynomial 4x squared plus 0x minus 1. That's 4x squared minus 1, and it was a difference of squares, so I got negative 1/2 and positive 1/2, which gave me all my opportunities, or all my, zeros. That gave me the 2 positives, 1 and 1/2, and the 1 negative, negative 1/2. Then when I did to 8, again, we went through that. I started with 1. I couldn't find it. I didn't want to do 7, so I went to 1/2, just thinking, well, maybe. Plugged that in, went through the whole thing. I had to work with a fraction. Thankfully, they were all even, so it came out pretty nice. Turned out that worked. But then I depressed my polynomial, and that was something I couldn't factor. So it looks like I only had one positive 0 on that one, which is a very reasonable answer. So those were all the rational zeros, all the kind of nice answers, but sometimes we're going to have zeros that fall between two numbers, and they are like the one that I talked about earlier, where I have an irrational number, where this is ugly, it's an ugly decimal. And so we have another very more organized way, and actually this method is going to be the method that we use most often when we're doing our graphing, and that is by making a very organized table. I'm still going to start the same way, and I'm going to go through that process where I figure out how many positive zeros and how many negative zeros I need, or I'm going to get. So my number of positive and negative zeros, I'll start with that. So my sign changes 1, 2, so 2 or 0 positives. And then in the negatives, I go through, this would be negative, stay negative, become negative, stay positive. So I only have one negative 0. I'm going to set up two separate tables here. One for positive zeros and one for negative zeros. And I didn't give myself a whole lot of space, sorry about that. Then I'll plug in these values. This is 1, -5, 1, and 8. Actually, I gave myself too much space is really what I did. And then for the negative zeros, I'm going to do the same thing. It's still the same number, so it's 1, -5, 1, and 8. But the difference is in the table, I'm going to do only positive entries. And in this table, I'm only going to do negative entries. Notice that when I set up my tables, I started out with 0 right away, because there are a whole bunch of numbers between 0 and -1 that are negative, and a whole bunch of numbers between 0 and +1 that are negative. So my 0 could show up between 0 and 1, and that's what we're talking about. These are between zeros. They fall between. There's some ugly decimal that falls between a whole number. And so what I'm looking for to find those zeros is where the value of y changes signs. Because if you think about it, I'm going to sketch a little graph over here. If I have a function, there's my coordinate plane, and if I have a function and it's kind of going up and down and moving around, if it goes from positive to negative f value, then it must have crossed through 0. And then if it goes from negative back up to positive, it must have crossed through 0 again. And so that's what I'm looking for results that change from positive to negative. So I'll just bring down my first number and multiply and add, multiply and add, multiply and add. And my starting point is 8. 0 is an easy one. It's just going to be a repeat of all those. But then I'll bring this down again, multiply and add, multiply 1 times -4 and add, multiply and add, and notice I'm still positive, so it must not have crossed through the axis. So then I'll try 2. Multiply and add, -6 plus 1 is -5, -10 plus 8 is -2. There we go. Right between here, there is a 0. So between 1 and 2, I have a 0. So I write that as between 1 and 2 is one of my zeros. Now I found one positive 0, so there must be another one in there. So I'm going to keep going until I find another change. So bring it down, multiply and add, multiply and add, multiply and add. I'm still negative. Put in 4, multiply and add, multiply and add, multiply and add. But I'm changing directions, so I'm getting closer. I went down to -7, now I'm turning back around. I'll try 5, multiply and add, multiply and add, multiply and add, and there I go. Change of signs, therefore, between 4 and 5, I have another 0. So I'm just looking where the signs change here. So I'm going to go through and do that same thing with the negatives. Again, this is my value. I know I need to find 1, so once I find 1, I can stop. So I'll multiply -1 times 1 and add. -1 times -6 is 6, plus 1 is 7. -1 times 7 is -7, plus 8 is 1. And I didn't find it yet, so I'll try again. -2 times 1 is -2, plus -5 is -7. Then I get positive 14, plus 1 is 15. -30 plus 8 is -22. And there we go, I found it. So I'm going to add my other one. It's between, this fell between -1 and -2. And so that would be how I'd list my answer. And so that means when I graph this, I have a 0 between 1 and 2, another 0 between 4 and 5. So this would be 1 and 2, 3, 4, and 5. I'm doing just a sketch there or whatever. It's not a great drawing. Then I have another one over here between -1 and -2. And so then that's going to help me when I do my graphs. So one thing that I have to remember when I'm doing a problem like number 10, I'm going to go through that same process, but when I'm doing a problem like number 10, notice this goes 4, 3, I'm missing 2 when I make my positive table. When I make my positive table and list my values, I have to do 1, -2, 0 for the squared term, 4, and -4. Then I'm going to make that same table for my negative values as well. But I'll start with my positive because I didn't plan on my room really very well here. And before I jump in, I need to find the number of positive and negative zeros. And so I have 1 sign change, 2, 3, so this is 3 or 1. Then this is going to stay positive, become negative, and then stay negative. So for here, my negatives, I only have 1. So I'll go through and bring my values down for 0, and I'll keep going through. 1, multiply and add, multiply and add, multiply and add, multiply and add. Put in my next one, multiply and add, multiply and add, multiply and add, multiply and add. I found my first positive 0. I am going to continue to work through this. In fact, I'm going to have you pause the video and work through and finish the rest of that, and then revisit me shortly, and we can compare our answers and do or set up and do our negative table. So when you work through these, hopefully you got to the solution where we get between 1 and 2 for the positives and between -1 and -2 for the negatives. Just want to address a big question that sometimes is out there. So we have 3 or 1. How do we know to stop at 1 here? How do I know not to go on? How do I know there's not going to be another 0? Well, on the positive end, if it's a positive function with no negative sign in front, obviously on the positive end, if it's a positive function, once you get to a point where it's all positives across the board, that means it's not going to change back to negative ever again, so we can stop there. If this were a negative function on the positive end, then I'd need all negatives there. When it comes to the negative side, I know to stop when I get to alternating signs. So it goes positive, negative, positive, negative, positive. Once I'm there, then I can stop. If you notice right above that, it was positive, negative, positive, positive, negative. So once I get to alternating signs. So when you get all one sign on the positive end, you know you can stop. When you get alternating signs on the negative end, you know you can stop. So I'm going to have you go on your own and finish off the rest, and then so pause the video and then come back and check your answers. And then of course you can come with questions when we meet again. But I do want to remind you that for number 11, I already found my positive number of positive and negative zeros. But for number 11, remember there's that missing x. So we have to go 1, -3, 0, and 3. If you forget that, that's going to pose a problem. And even on number 12, if you look at it, it goes 4, I'm missing 3 and 2. So when I set up my value, I'm just going to slide a piece of paper in front of there. When I set up my value for that one, here we go, I'm going to have to do 2, and then, I should put that over here so you can see, and then a 0 for the x cubed, a 0 for the x squared, -2 and -3. All right, so pause the video. Good luck finding your answers, and then when you're done, come and check and see how you did. For number 11, I got between 1 and 2, 2 and 3. And then for the negatives, I got between 0 and -1. Again, notice I'm alternating signs, so I knew I could stop. Here, I got the 2 that I needed, so I knew I could stop. And then for number 12, between 1 and 2 and 0 and -1, and so here's my work that goes with that. I just kind of ran out of paper. Those happened pretty quick. Now, the ones we did in the notes happened, again, like I said, pretty quickly, except for that first one where we got down between 4 and 5. I believe there is one on the homework assignment that gets between 6 and 7. So, no, just watch out for those little signs. Make sure you find your number of positive and negative zeros, because it really does give you an idea. Sometimes it'll tell you when you can stop. If it's not real clear when you can stop, like I said, if you get an issue like we did with this one where we had 3, and I wasn't sure if I was going to keep going or not, then you look for that indicator. Am I all positives or all negatives in the positive one, or am I alternating signs? Your homework then is 12-2, evens or odds, and of course come with questions. We'll talk soon.